So go ahead and practice with these problems right here. Just do 5 through 13 odd, 23 through 27 odd. You definitely will need some graph paper. And so once you get this done, make sure you bring them to class and we'll have some more to practice with. Okay? Let's talk about exponential growth here. To begin this off, we're going to go ahead and just take a look at what exponential growth looks like. We're going to do a quick graph here. And so I start off with just a real basic one. It's y is equal to 2 to the x power, right? So really what we're saying here is we're saying I have some multiple of, or not multiple, but I have some power of 2. So I'm going to have 2, and I'm going to raise it to some power, and then I want to see what happens, or what comes out of that. So what I did is I just set up a quick little chart here, and I said, okay, if x is going to be 0, 1, 2, 3, and 4, well, what would be the results? So let's do this. Let's put 0 in for x here. And so I would have 2 to the 0 power, right? This would be equal to 2 to the 0 power. Well, 2 to the 0 power is going to be 1. Okay. And if I put in 1 here, this is going to be 2 to the first power, and that's going to be equal to 2. And then if I take 2 and I plug it in up here, it's going to be 2 to the second power, which is going to be 4. And if I plug in 3 up here, I'm going to get 2 to the third power, which is going to be 8. And then finally, I'm going to take 4, right, 4, and plug it in up here, and I'm going to get 2 to the fourth power, and then that's going to be equal to 16. And then let's go ahead and put this on the graph, and let's just get a quick glimpse of what this looks like, right? So if I start at 0 here and I move over 1, okay? Actually, if I start at 0, my y-intercept here is going to be 1, right? Because any exponent, if the exponent is 0, the result, no matter what, is always going to be 1. Okay, so make sure you keep that in mind. Remember, if the exponent is 0, your result will be 1. Okay, well, if I plug in x is 1, then I have y is 2. And then if I go 2, I go over to 4. And then if I go over to 3, it goes up to 8. And then if I go over to 4, I'm going to go up 16. All right, let's make sure I got 2, 4, 6, 8, 10, 12, 14, 16. Okay? And really, this is a very basic exponential function, right? I'm just doing powers of 2, which is sort of the most basic of all of the powers I can do. It just doubles, right? So this is each time I'm going to have twice as many things. And this goes back to kind of the penny problem that we were talking about in class, or you could talk about cell division, okay? At the beginning, we start with one cell, and it divides, and I have 2. And then these 2 divide, which give me 4. And then these 4 divide, and I get 8, and 8 divide into 2 and get 16. And on and on and on. And so each of these values show how many you have at the end. Right. Well, let's look at this and let's sort of think, okay, well, what if exponent is -1? What's that going to mean? Well, that's going to mean -1 goes in here, right? And then so 2 to the -1 is going to be equal to 1/2. Okay, so if I graph this, I'm going to go over to -1, and then I'm only going to go up a half from here. Okay, and if I go 2 to the -2, right? If I make x -2, well, then that means do another half. So I'd say 2 to the -1/2 is equal to 1 over 4. So then I'm going to get 2/4. Okay? And it's going to just keep going and going and going. And what I want you to think about is, as this number gets more and more and more negative, what's going to happen to this? Okay? So think about that. What's going to happen to the value of y, right? The value of y here, as I keep going further and further negative. Think about that. Well, while you're kind of thinking about it, let's go ahead and you can kind of graph this, right? And so this is going to end up being a curved line, and it's just going to go straight up, okay? And it doesn't have to be perfect, but the idea here is that you see as time moves on, right? As we get x gets bigger, y gets bigger quickly, right? And if you keep going here, it's going to just shoot way up the graph, right? If I end up over here somewhere, it's just going to shoot way up there. Just like when we saw in the penny problem, 2 to the 30th power is like 107 billion, or 107 or 1 billion, something like that. Okay, so that's a big number, so it gets big very quickly. Well, let's think about this idea again as this comes down and gets on and on and on and on. And what I want you to think about is, will this line ever touch here? Will this line here, will it ever actually touch the x-axis? And what I'm hoping, as you see, is well, the x-axis is where y is equal to 0. Okay? And if you keep dividing this in half, sure, you'll get really, really, really close to 0, but you won't actually ever get 0. You will have a very, very small amount, but it won't actually be 0 itself. Okay? So this is a basic exponential growth graph, okay? And I'm hoping this kind of makes sense to you, right? And another thing is, if let's say I go this way, right? As I keep moving on and on and on, as x gets bigger and bigger and bigger, what's it going to get closer to? Well, hopefully you see that the bigger it goes, the closer it's going to, it's going to start moving towards infinity, right? The numbers are just going to get really, really big, and so it just goes on up forever. And so what we can do here is we can talk about the range, right? The range in this, okay? The range are the set of all of numbers that can come out of this, okay? And in this case, the range, all of the numbers that can come out of this are any number, right? Y, anything that's greater than 0. Now, it can't be equal to 0. I can never get this thing to be equal to 0, but it can be greater than 0. Okay? And it can't be negative either. I can't get it to be negative at this point. Well, and if we look at this, right, our domain, right, the domain is what numbers can I plug in? Well, what numbers can I use for x? What numbers can you plug in there? Well, if we look at it, I can use negative numbers, I can use positive numbers, I can use 0. And so really, this is just all real numbers. Okay, and another way of doing this is this double R, okay, like an R with an extra bar on it. Okay, the set of all real numbers. So that gives you a kind of general idea of domain and range. There's a really good Khan Academy exercise on domain and range that will really, I think, help kind of solidify your understanding of what domain and range mean. And you're going to really need to know those for exponential growth, exponential decay, and especially when we start graphing parabolas. Okay, so if you haven't done that one already and you're a little bit sketchy on domain and range, then please go do that. Okay. Well, let's go ahead and let's take a look at let's take a look at a definition here, okay? So an exponential function is a function in the form of, okay, y equals a times b raised to the power of x, okay? Where a cannot be 0, right? Because if this thing is 0, then the whole thing turns 0. B has to be greater than 0, okay? We're not looking for this to be a negative number. And b cannot be 1, okay? Because if this is 1, then this whole thing is going to be 1, and then it's just y equals a. So we'll try to avoid that. Okay, so this is the exponential function form, right? And so it's kind of like your exponent form. Like when we had linear functions, it's y equals mx plus b. So this one is y equals a b raised to the x power, okay? And so exponential functions, they're nonlinear. And really, nonlinear just means not a line, okay? So these are not straight lines. They're going to be curved lines. They're going to grow really quickly. They're going to fall really quickly, okay? They're not going to grow or decay or go down at a steady rate, okay? So hopefully this makes sense. And I think it will make it once we do a couple of examples here, okay? So let's do this. Let's take a function and write a rule for it, okay? So let me give you an input-output table here, okay? Where x is negative 2, negative 1, 0, 1, and 2. And my output here is 2, 4, 8, 16, and 32. And what we're trying to do here is we want to write a rule, okay? We want to write a rule where this function, right, will be true. So let's go ahead and I'm going to come back here for a second, and I'm just going to turn so that I can write on top of this. All right, so let's look at this. Okay, so as x increases, Okay, as x increases here, it goes from -2 to -1 to 0 to 1 to 2. It increases. As it goes up by 1, what happens to the values of y? Okay, and so what I'm hoping you see here is, okay, let's find what the first we want to find if it's exponential. Okay, and so sorry, let's take a look here. Right, as x goes up by 1, y is being multiplied by 2, right? From 2 to 4. Maybe you at first you say, okay, add 2, but then that rule doesn't apply here. 4 plus 2 is not 8, it's 6. So you say, okay, well, maybe multiply by 2. 2 times 4, okay, 4 times 2 is 8, 8 times 16, or 8 times 2 is 16, 16 times 2 is 32. So it works, okay? And so now what we're going to do is we're going to look at, okay, my result, y, is going to be equal to some number, okay, base of 2, that's being raised to some power. And we're going to look to see, is there a multiplier, right? Is there a multiplier for this for this problem, okay? And the easiest way I think you can do this is you look to see what is the value of y when x is 0. Because remember, if you plug this in, right, you know that 8 is y in this case, okay? And we're looking to say a times, and you know that 2 to the 0 power is going to be 1. So you're going to get 8 is equal to a times 1. And so this is getting a multiplier of 8, okay? And that means what we can do here is we can say, okay, y, okay, my output is going to be equal to some power of 2, and it's going to be multiplied by 8. Okay, and let's go ahead and test it. Let's plug in. Let's start with maybe like an easy one, like 2. So plug in 2. 2 squared is 4. 4 times 8, 32. It works. Let's try this one. 2 to the first power is 2 times 8 is 16. All right, it works. 2 to the -1. Okay, well that means 1/2. Well, what's 1/2 times 8 is 4. Good. 2 to the -2. Plug that in here. That's 1 over 4. 1/4 of 8 is 2. So we have a function rule here. Okay. And that's how you do that. We're just kind of looking to see, can we find the pattern and write a rule around it. Okay, so I'm going to go ahead and delete this. And the next couple slides here, I'm just going to quickly go through. It just sort of says, excuse me, it says, typed out here what I just explained. So if you need to pause it and read it, you can do that. I'm just going to kind of quickly step through here, though. Okay, so again, there's our function rule. Okay, now let's do this. You try it. Why don't you go ahead and you decide, you look at this and you try to say, okay, first, is this an exponential function? And if so, what is the base? And then, what is the actual rule? So remember, we're looking at it for y is equal to a times b to the x, okay? And you need to fill in a and b. So go ahead and see if you can do that. Pause the video. Okay, well hopefully as you looked at this, you said, okay, you know what? This goes up by 1. And that goes up by 1. And that goes up by 1. And this goes up by 1, right? And so as it goes up by 1, what's happening here? Okay, well 3 to 9, that's, let's say, up 6. 9 to 27, not up by 6, okay? 3 times 3, 9. 9 times 3, 27, times 3, times 3, so that looks like it works. Okay, so I know that my base is going to be 3 raised to some power. Now again, let's take a nice variable like or a nice exponent like 0, right? So then we know we're going to plug it in. I know 27 is y, I know 0 is x, and then I can solve for y. So 27 is going to be a times 3 to the 0. Right? Well, this becomes 1, so 27 is equal to a. So then we know that our function rule here is y equals 27 times 3 to the x power. Okay? Right? And let's go ahead and you're going to see some more words again. It's kind of all written down what I just explained. Okay, and this is the same answer. Okay, we already actually graphed this one, and we identified its domain and range. So I'm going to kind of skip through these. Okay, and then let's say, okay, let's try this. If we're going to graph the functions 3 times 2 to the x and negative 3 times 2 to the x, and then compare them, what's that going to look like? All right. Well, I'm going to go back to, whoops, not that one. I'm going to go back to, oh, sorry here, my original graph, okay? And what we're looking to do here is, okay, I'm going to go ahead and I'm going to clear all this, okay? The blue one up there, that's kind of our base one, right? And we decided this was y is equal, this is 1 and 2 and 4 and 8 and 16, okay? Now, we also want to do, we'll do one in red here. And the red is going to be y is equal to 3 times 2 to the x. Okay, and so we'll make a x and y chart. And then we also want to do one, and we'll do this one maybe in green. We also want to do one. I'm going to just kind of do it down here. We'll do y is equal to negative 3 times 2 to the x. Okay. And we'll go ahead and graph all those. Okay, and let's make a quick little x and y. Okay, and I'm just going to use the same values. 0, 1, 2, 3, 4. We'll do 0, 1, 2, 3, and 4. And then we're going to just graph each of these. Okay, so let's start. We'll graph the blue one. Okay, so we actually already did this one. It's going to be 0, 1, 1, 2. Then we go up to 4. Right. So since we're going to go over 1, so it goes up 1. We go over another one. Sorry. Then 2, and then we'll go up 4, and then we had over to 3. Or 4 was 16. Okay? So these match up with this table here. We can go ahead and we can look at it as a curved graph like that. Okay, now let's do the red. Okay, so if x here is 0, 2 to the 0 is 1, 1 times 3. Okay? 1, 2 to the first power is 2 times 3 is 6. Right, 2, we'll say 2 squared is 4. 4 times 3 is 12. Okay. And then 2 to the third is 8. 8 times 3 is 24. And really we can see is you're just taking these and multiplying them with 3, right? So 16 times 3 is going to be 30. What is that, 54? No. 72? No. Why am I having bad math right now? Bad time. Let's see, 24, it's going to be, what? 16 times 3 is 48. Okay. Sorry, I was having a brain fart there. And really, what I could have done, instead of multiplying this by 3, these are just doubling, right? Because that's the whole idea. It's doing a power of 2. Okay, so then let's go ahead and graph these. So we start at 0, and then now this time we start at 3. And then at 1, we go over 1, 2, 6, okay? And then 2 is at 12, so it's 6, 7, 8, 9, 10, 11, 12. And then it's going to go on. It's not even, we can't even put it in there, right? So this one is going to go like that. All right, and then let's go ahead and we'll graph our green one. Okay, and so we have 2 to the 0 is 1. 1 times negative 3 is going to be negative 3. And in fact, I can really just populate this chart here with the same ones from here and just make them negative. Right? 3 times 24 is negative 24. And then this one is going to be negative 48. And we'll go ahead and graph these. So then this is going to be 1, 2, 3 down here. And then we're going to go over to 1 and we'll go down 6. And we don't even have enough room, so this thing is just going to go like this. If you look at it, really, it's just this red one, okay, flipped over, right? It's just flipped over the x-axis there, okay? And so as we look at this, okay, if we're going to compare them, let's look and say, okay, here's my base one, right? So I went up 1, okay, we start at 1, and so then 1, up to 1 times 2, 2, right? 2 to the first power, and then 4. Okay. Well, here in this one, we start from 3, right? So then let's see, we'll go 1, 2, 3, 4. Okay. And then this one is 1, 2, 3, 4, 5, 6, 7, 8 away. Okay. And as this keeps moving on up and up and up, okay, this one is going to grow at a rate that's 3 times faster than your base one. Okay. So